Hi, I'm the calculus professor, and today we'll be talking about areas between curves. In problem number 11, we'd like to find the area of the region that's bounded by three curves. And those three curves are y equals e to the x, y equals e to the negative 2x, and x is equal to the natural log of 4. Okay, so before we start trying to do anything here, we need to get an idea of what the region looks like. So my suggestion would always be, before you start these things, draw the region to the best of your ability. So let's do that real quick. So here's my x and y axis. Y equals e to the x looks something like this. Y equals e to the negative 2x looks something like this. And then x equals ln of 4. Ln of 4 is just some positive number, and so it looks like this. Okay, so the region bounded by those three is sitting right there. So now we have some sort of a picture of the region that we're interested in, and what we see right off the top is that there is a top function and there is a bottom function starting at some x value and ending at some x value. So we want to integrate this thing with respect to x, starting at an x value, ending at an x value, and then we want to integrate the top function minus the bottom function. So let's do it. It's easy here to see the x value that this starts at, that's 0, and it's easy to see the x value it ends at, that's ln of 4. So we can start this off by saying, okay, our area that we're looking for here is the integral from 0 to ln of 4 of the top function, which in this case, our top function is e to the x, minus our bottom function, which in this case is, let's see, I didn't write it in here, but this is y equals e to the negative 2x. So we want to subtract e to the minus 2x dx. All right. If you want to, we could rewrite this real quick, and we could rewrite this as the integral from 0 to ln of 4 of just e to the x minus e to the negative 2x dx. Let's take an antiderivative of that. Antiderivative of e to the x is e to the x. And the antiderivative of negative e to the negative 2x is positive 1/2 e to the negative 2x. And that's evaluated from 0 to ln of 4. Okay, so let's go ahead and plug in ln of 4 here. So if I plug in ln of 4 to e to the x, I get e to the ln 4. If I plug in ln of 4 here, I get plus 1/2 e to the negative 2 times ln of 4. Okay, so that's plugging in ln of 4. Now I need to plug in 0. So I'm going to subtract. If I plug in 0, I get e to the 0. And then I get plus 1/2 e to the negative 2 times 0 is still just 0. So e to the 0. All right, let's simplify this a little bit. E to the ln 4, e and ln are inverse functions of each other, so that's just 4. Here, this one's a little more complicated, but not too bad. We can use the power rule for natural log to bring the negative 2 up as an exponent of the 4. So let me just rewrite it once. I'll just say that this is 1/2 e to the ln of 4 to the negative 2 power. Then we get minus e to the 0, which is minus 1. And then we get minus 1/2 e to the 0, which is minus 1/2. Okay, let's put that all together. And we have, this is the guy that we have to have a question about, but it's not so bad. This is 4 plus, this is 1/2 times 4 to the negative 2. So this is 1/2 times 4 to the negative 2. And then I get minus 1 minus 1/2. All right. What's 4 to the negative 2? That's 4 on the bottom squared, which is 1/16, and 1/16 times 1/2 is a 32nd. So this is 4 minus 1 is 3, minus 1/2, and then plus this guy, which we said was 1 over 2 times 16, which is 1 over 32. If we want to write all of this as 30 seconds, then we would get that this is, well, 3 is 96 30 seconds. 1/2 is minus 16 30 seconds. And then we get plus 1 32nd. And we get 96 minus 16 is 80. Plus 1 is 81 over 32. And that is the area that would be trapped in this shaded region.